Okay, so let's start chapter 7, which is on the topic of quadratic functions and equations. And section 7.1 is exploring quadratic relations. Okay, so a lot of this isn't going to help you right now, but it will as you get going. So make sure you come back to this front page. There's a lot of information here that will be handy later, okay? So first of all, it says the degree of all quadratic functions is 2. So if you can remember from Math 10, when we talked about degrees. Degrees is the highest exponent. And the second bullet here says that the standard form of a quadratic function is ax squared plus bx plus c. And so 2 here is the highest exponent. That's why the degree of all quadratic functions is 2. Okay, so in order to be quadratic, it has to have a squared. Okay, if in the equation it has a cubed, it's not quadratic. If it just has an x, it's not quadratic. If it's to the power of 4, it's not quadratic. The highest exponent has to be x squared. So an example of a quadratic function might be x squared. Well, y equals, because it's an equation, y equals x squared plus 2x plus 1. That's an example, okay, because the highest exponent is x squared. Another example is just x squared plus 1. It doesn't have to have that middle term, okay? It just has to have an x squared. Or it might be y equals x squared plus 2x, okay? So it doesn't really matter what comes after as long as the highest exponent is x squared. Okay. Now, this other stuff talks about the graph, and it says the graph of any quadratic function is a parabola. Okay, so that's what they're called with these properties. First of all, the parabola has a single vertical line of symmetry. So right here, there's 2 examples of parabolas. I'm going to highlight them. Here's one. That's an example of a quadratic function graphed, making a parabola. And yes, it looks like a happy face or a smile. And this looks like a frown. Okay, and that's another example of a parabola. So the graph of a quadratic function. So it says the parabola has a single vertical line of symmetry, which we show with a dotted line. Okay, line of symmetry is a line that goes exactly through the middle, and the graph is exactly the same on both sides. Okay, so it has a vertical line of symmetry. Even if it's opening downwards, there's that line of symmetry. It's the line that's right through the middle, and my parabola is exactly the same on either side. The highest or lowest point of the parabola lies on its line of symmetry. Okay, so in this parabola, right here is the very lowest point of the parabola. Because it's the lowest point, we call it a minimum. Okay, min for short, but it's a minimum. It's also called the vertex. It's the absolute lowest point of the parabola. This parabola goes up forever, so it's never going to have a highest point because it goes on forever, okay? So it's the minimum point of the parabola. Or if the parabola opens downwards, this vertex is the highest point, and so we'd call that a max because, of course, it's the maximum point in terms of height that we will ever have for the parabola because the parabola opens downwards forever, okay? So the highest or lowest point on the parabola lies on its line of symmetry, and we call it a max or a min. But in either case, it's the vertex. The vertex is the highest or lowest point of the parabola. If a is greater than 0. Okay, so let's back up. Man, I've done a lot of writing on here. Let's erase all this stuff. Come on, erase, please. Get rid of that. Okay, now it says if a is greater than 0, where you're like, well, what's a? So remember that the standard form of a quadratic equation is ax squared plus bx plus c. A is that coefficient in front of the letter. So an example of a quadratic function could be 4x squared plus 2x minus 5, something like that. Okay, so here's a, here's B, and here's C. Okay, if you've ever taken physics, this will seem quite familiar to you because you've done quadratic equations before. So if A is positive, meaning it's greater than 0, it opens upward. Okay, positive people smile. If a is less than 0, so maybe the equation is negative 2x squared plus 4x minus 9. I don't know, I'm just making something up. If it opens downwards, well, negative people frown. So if a is negative, it opens downwards. So that's a nice, easy way to remember it. And then it says the y-intercept of the parabola is c. So whatever this number is, that's where it cuts through the y-axis, okay? And the reason why that is because when you are going through the y-axis right here, x is 0. So if you plugged in x is 0, it makes that go away. And if you plug in x is 0, it makes that go away. And it just leaves that last point, okay? This is going to be really handy. So again, might not make a lot of sense to you right now, but it will eventually. Okay, so the first example we're going to cover here, or the only one on this lesson because it's nice and short, says a quadratic function is defined by y equals negative x squared plus bx plus 3. And it says make a prediction about the effect on the corresponding parabola when the value of b is varied, and test your prediction by trying several values of b. So what I want you to do right now is I want you to go to our page for chapter 7, and I want you to open up this graphing calculator, and I'll show you how to use that. You're going to use this from time to time through this chapter. You do need to know how to graph by hand, but you also need to use this. All right, so continuing on, we are going to play with the function of negative x squared plus bx plus 3, okay? And make a prediction about the effect on the corresponding parabola when the value of b is varied, okay? So let's take a look, first of all, because the general form of an equation is y equals ax squared plus bx plus c. So right here, even though it just says negative, that's my a. My a is negative 1. So remember there'd be a 1 right there that you couldn't see. B, I don't know. I've got a b sitting where b is, so that's the number we're going to play with. But c is 3. So already from my equation, I know because a is negative that this parabola opens down. It's a negative parabola, so it's going to look like this. It's a down. I know that my y-intercept is 3. So I know my graph is going to cross the y-axis at 3. And then what we're going to do is we're going to play with that middle term b. We're going to see what happens, okay? So it says, what happens when we change b to 0? So my equation would be y equals negative x squared plus 0x, because we're replacing b with 0, plus 3. Well, you know, anytime you multiply anything by 0, it just goes away. So actually, this equation is just going to be y equals x squared. Oops, that's attached now. Plus 3, okay? So I want you to go to this graphing calculator, and we're going to play with it. We're going to graph y equals negative x squared plus 3. So go to this graphing calculator. Pause if you have to, but if you're there, you can work with me. Okay, so negative x squared. So you're going to type in a negative, and then type an x, and then type this for squared. See how that worked? Now, look at the graph of negative x squared, but remember that the equation was negative x squared plus 3. Remember I told you that the graph has to go through the y-axis at 3. So we're going to type plus 3. And look what happens with my graph. So it opens downwards like I told you. Its highest point is 3, and its x-intercepts right here are not very pretty numbers, 1.732 and negative 1.732. So if we were to sketch it here, I have my y-intercept, my x-intercepts from the graphing calculator were 1.732 and negative 1.732. And then freehanding it, it would look something like that. remember that parabolas are symmetrical. So here's my axis of symmetry, right? Oops, right down the middle. There. Here's my vertex. My vertex is the highest or lowest point of my parabola. And because this parabola opens downwards, it's a maximum. Okay? So that's what the graph of y equals negative x squared plus 3 would look like. Okay, now we're going to try it again. It says, what if you changed it to 1? So my equation is going to be y equals negative x squared plus 1x plus 3. Now, you can put the 1 or you don't have to put it. Either way, 1x is the same as x. So let's go to the graphing calculator. I'm going to add an x. You can type 1 if you want, x plus 3. So have a look at what adding that 1x did to the graph. Now, my x-intercepts are different. Look at how they've moved to the right. My graph is still going through the y-axis at 3, but now my vertex is higher. Here's my vertex, right there, the highest point. So my parabola now looks something like that. So what happens when b became 1? It got bigger. My graph moved to the right, and it moved up a little, didn't it? Okay, let's do it again, but now we're going to change it to 2. So y equals negative x squared plus 2x plus 3. What do you think is going to happen? Do you think it's just going to move over more and go higher? No matter what, my intercept's 3. This part's not going to change right here. Oops, let's go here. So I'm going to change that to a 2x. Okay, here's where it was. Did it move more to the right? That was x. Okay, look at your x-intercepts here. Your x-intercepts are negative 1.3 and 2.3. If I change that to a 2, my x-intercepts definitely move over. Now they're negative 1 and 3, and my vertex is at 1. It used to be at a half. So yes, when I make that bigger, my graph moved over more and went higher more. So again, moved to the right, and my vertex got higher. So then, if I make it negative, so my equation would be y equals negative x squared, still opens downwards because my a is still negative, minus 1x plus 3. Pen is working horribly. All right, so I'm going to change this to negative x. Okay, so look at what happened to the graph now. So it moved down. Remember, it was 2x. This is what 2x looked like. Oops, my x. There we go. Remember, that's what 2x looked like. Now, we can graph another one. Negative x squared minus x plus 3. So look at how it is compared to that last one. I have moved to the left, and my x-intercepts are moving as well. Okay? So when I make that middle term negative, now I'm moving this way, and I'm moving down a little. And then if we change it to negative 3, so my final equation is y equals negative x squared minus 3x plus 3. Probably what you suspect will happen at this point. Let's do it again. Negative x squared minus 3x plus 3. Still going through the y-axis at 3. Look at how it got higher. Remember how when we had 1 and then we went 2, it went higher? So here we had negative 1 and now we have negative 3. Look at how my vertex got higher. So I can say that I went more left, but my vertex got higher. So as this gets bigger, I go higher. But if it's positive, I'm going more to the right. If it's negative, I'm going more to the left. So in section 7.1, you don't know how to graph parabolas yet. We're definitely going to talk about that in this chapter, but right now you don't know how to graph parabolas. So right now, use this online graphing calculator to play and to see what parabolas will look like. All right, so good luck on your practice.